Hello and welcome to the final video of my object-oriented class. In this video I'm going to be going over the final we had for this class, and yeah, it's just a program I built, so I'll be going over my code and that's about it. So first off, the program that we were required to create was it was like a parking app that handles parking spots, and it's supposed to handle when a user comes and they want to park their car, and then when they want to unpark their car, all that, just how a parking spot works. We want to hand out a ticket every time a user parks a car, and then use that ticket to unpark the car. And yeah, I'll be going over how I created this. So first thing I'm going to be going over is the class models. The classes that are going to model certain objects that we need for this program to run. The first one is a parking spot. So obviously, as the name implies, this class models a parking spot, and it's going to have two It's going to have two attributes. It's going to have an ID and then vacant, because that's pretty much the only thing a parking spot needs. It needs an ID to know which exact parking spot and where it is, and then if it's vacant or not, like if it's open or not. And those are the only attributes we need. So inside the class here, we define the constructor, which obviously takes two parameters. Self is always included, but two parameters. It takes an ID and then vacant. And the first thing it does, it just sets the ID we pass as ID. Pretty self-explanatory. Then over here, it's gonna expect either a 1 or a 0, and this is because when we want to store our parking spots, because obviously when the program shuts down, we want to store it somewhere, and we're gonna be storing all the data inside of a CSV file, which I'll explain later. But in the CSV files, instead of true or false for vacant, we just have a 1 or a 0. 1 means it's open, so it's vacant, which means vacant is true, or a 0, which represents false, which means vacant is false, which means it's not open, right? So it's expecting either a 1 or else it'd be a 0. So expecting either a 1 or a 0. And if it's a 1, it sets the vacant attribute to true, and then else, which is a 0, it's going to set it to false. And the way we know it's going to be a 0 is because this is all going to be internal, and it's going to be private. Like only the program itself is going to access this attribute of parking spot. So we can make the assumption that it's either going to be a 1 or a 0. So yeah, so this is how we construct the class when we want to create a new one. And then we just have some getters for the ID and vacant in case we needed it. And actually, I don't use it in the program, but it's in there because it's always good practice. And then the next class is a parking lot, and the parking lot is going to contain the parking spots, obviously. And the way it's going to work is we obviously have a constructor, and it only takes one parameter, which is parking spots, and it sets its attribute parking spots to the parking spots we pass in. And the way this program is going to work is we're going to store all the data of parking spots in a CSV, and then we're going to load them into our program as a dictionary in order to work with the different parking spots. And that parking spot dictionary is going to be contained in the parking lot. So this is expecting a dictionary of parking spots, if that makes sense. So it just sets it over here as parking spots. Now what we're going to do with that inside of the parking lot class, where the real magic happens, I guess, is the methods it has. It has a couple useful methods that we're going to need. So the first one is, where is it? Here, which is get empty parking spot. Basically what it does, it's gonna iterate through the parking spots dictionary and find a parking spot object that's vacant and return it if there is one. If not, it just returns false. So as you can see over here, we do for key in parking lot spots. If self.parkingspots with the key that we feed in is true, we return the parking spot. Else, or no else, we just return false. So basically, it's going to iterate through all the objects within the dictionary, and until it comes across an object with a vacant attribute set equal to true, it's going to keep going, and once it does, it's going to return it. But if it never does, it just returns false. Basically, that's what it does. So this is how we check. We find an empty parking spot, and we also check if there even is a empty parking spot. Then over here we have a set vacant, which takes an ID as a parameter, and it basically takes that ID and goes inside the dictionary to find the parking spot associated with that ID, and it sets vacant to true. And then set occupied does the same thing, but this is wrong actually. It should be false. But it sets vacant to false, meaning that a parking spot has been occupied. Then we have a getter for a parking spot within the dictionary. We just take the ID and it returns the object parking spot. Then the next class is a ticket class. A ticket class is just going to store info about a certain ticket that we hand out. A ticket is how we identify the car, the parking spot that the car is parked in. It's basically the main object where all the main info is stored. So when a ticket obviously is going to contain an ID, which is how we identify it. It's going to contain a vehicle license plate, which is how we're going to identify the vehicle. And it's going to contain a parking spot ID, which is how we identify what parking spot the vehicle is currently parked in. And then we have a vehicle type, which we need it when we want to differentiate between if the car is a truck or a car, which we need to. And it made most sense to keep it in here inside the ticket, so it's stored in there. And over here it's just a constructor which sets all those attributes to what we pass in over here. Nothing crazy. And then the final set of classes is, the first one is a vehicle class, which is going to have a license plate and an owner name. And the other two classes inherit from that vehicle class. The first one is a car, and it has the same parameters or same attributes, but on top of that it has a number of doors, which it sets over here. And the same thing for truck, but instead of number of doors, it has a payload capacity, which it sets over here. And these classes are the ones that we use to work with the car that the user parks. Then the other functions we have is create parking spot CSV. Basically, what this function does, it creates a CSV in your machine when you run it that contains all the necessary headers, and it loads all 100 parking spots in the CSV. And that CSV is what's going to store the data of the parking spots. So what it does is it with open, and then we create a parking spot.csv. We write to it the following. So we create a letters array, and it's A through J, and then we say for I in range of 1 to 11. It's going to start at 1. It's going to go all the way to 10. And then for letters and letters, so for every letter in here, we're going to write a letter plus the number. So the first iteration is going to be A1, and then and then B1. It's going to go like that, and so on for the 100 parking spots. And then it's going to say plus, and then a semicolon, and then a 1, and a new line. And what all this is saying is, it's going to set the ID, which is first the letter and then the number, and then it's going to set a 1, which represents vacant, and it's going to write all that into the CSV file. So it's all going to be just a column with IDs, and then on the other side it's going to be ones, which represent vacants, and that's going to model a parking spot, or the parking spot object or class. And we just run this once because it's just when we're beginning the program, we want to load those parking spots, and then that's the only time we really need to run it. But that's what it does. Then we have create ticket CSV. Again, it does the same thing, only this time it does it for a CSV that contains the tickets. And here it just writes, because obviously in the beginning of the program we don't have any tickets handed out just yet. So what it does over here, it just writes the headers, and it just has a header ID, vehicle license plate, parking spot ID, vehicle type. Again, it's just the same pattern as the object, or as a class for tickets. And then we have another one for cars. Again, it just creates the headers, creates a CSV with the headers, and again, ID, owner name, number of doors, just the same pattern as the class. And the same thing for truck, only this time, you know, payload capacity. And yeah, so that's what these do. They just create the CSVs that we need for the program to actually work. And then, hold on, let me pause this. Okay, sorry about that. I had to pause the video. Now, continuing on. The next function I created for this program was it's called load parking spots. And basically the job of well, all the load and then whatever comes after functions is to read a CSV and create create objects and then return them. In this case, we want to return a dictionary of objects from a CSV file, and it's load parking spots. Because the way the program is going to work is the parking spots, all 100 of them, are going to be loaded in as objects, and we're going to have them in our local memory. And then from there, we're going to work with it and perform whatever actions we need to. But then objects like the ticket or a car or a vehicle, we're just going to load the one that we're working with into local memory, and then the rest are going to stay in there. So for the parking spots, we're going to load all of them and return a dictionary of all 100 objects of parking spots. And that's the job of this function. So obviously it has to read the file. So with open parking spot.csv as read, with the read I guess mode on as file. First, what we do is we create a raw data, because we still have to parse through the data in order to create objects out of it. So first thing we want to do is we want to read all the lines into raw data, and that's going to return a list of all the lines. So every element inside that list is going to be a line in the CSV. And then we create we just initiate a variable called data, and we set it to a blank list. And for line in raw data, so for every element or every line that is loaded into that raw data, we want to append it to data. And what we want to do is we want to strip it because it's gonna contain some escape characters in there. So we want to strip it all, and then we want to split at the parentheses, because again, when we write to a CSV, we got to include that parentheses to tell the program to go to the next cell. So we want to split there, and it's going to split the strings and remove this. So it's just cleaning up the string, and then we append it to data. So now data contains So now data is a 2D list, with the first element being a line, and inside that the first element is the ID, and the second element is either if a 1 or a 0, depending on if the parking spot is vacant or not. So we take those and we create a parking spot. I'll get into this over here, but we take that row, and the first element again is going to be the ID, and the second element is going to be a 1 or a 0 depending on if it's vacant, and we pass that into a parking spot, which creates an element of a parking spot class. So that's what's going on here. But we want to load it into a dictionary again. So what we do is we create an empty dictionary, and then for row and data, so for every line that we read, we are going to create inside the dictionary, we're going to add row, and then the first element of row is going to be the ID. So we want the key for this, we want the keys in this dictionary to be the IDs. So that's what we do over here. The row with the first element of row contains the ID. So the key in this dictionary is going to be an ID, and the value of it is going to be the parking spot I talked about that we create. And it's going to do it for every single row, and every single row represents a parking spot. And it's going to load it all into this dictionary, and then we'll return the dictionary. Basically, behind all this, it's going to read the entire CSV, and it's going to return all the parking spot objects inside of a dictionary with their keys being their own ID, which makes it easier to work with. And that's basically what this does. That's the only job of it. Now, onload parking spot does the exact opposite. Here, it takes the dictionary that we created, in the same format. It's got to be in the same format. It takes that dictionary that we return, and it writes it all back up into the CSV. Because again, how this program is going to work is we're going to load all the objects in, and then we're going to make whatever changes we need to, and then at the end of the program, we just write it back into the CSV. We're not going to pick one out at a time, and then, you know what I'm saying, just do one at a time. No, we're going to load them all in, make whatever changes we need, and then load it all back in. And obviously to load it all back into the CSV, we need a function to do that. So again, this function takes a dictionary as its parameter, and what it does, it writes to the same file, and it has a W, which basically overrides. It's not going to append, it's going to clear it all up and write it back in. We got to write every single one. So what we do is for key in dictionary, which is how we just iterate through a dictionary, we're gonna write it into the CSV. But first, if you remember, the way the parking spot object works is it's going to contain vacant, and it's either going to be true or false. But inside of the CSV, it's not going to be, we don't write true or false. We write either a 0 or 1. So we got to convert it back to either a 0 or a 1. So what we first do is we take vacant and we set it equal to none. Okay, and from here we got to figure out if we're going to set vacant either to a 1 or a 0, depending on if it's vacant, right? So what we do is we check if dictionary, or if the current object, if the current parking spot, because dictionary with the key value just returns an object with that ID or key. We're going to check if that current object, if the vacant property is equal to true, which means it's open, we set vacant equal to 1. And then else, which means it's false, we set it equal to 0. So this handles converting from true or false into a 1 or a 0. So that's what's going on here. So now we know what vacant is, and all there is to it is to write it back into the file. So what we do is we create a string. We're just going to parse it. First thing we do is we write the ID, because again, the way writing to a CSV works is you write whatever string you want, and then you put a comma, and the way the CSV handles that comma is go to the next cell. So in the first cell again is going to be the ID. So we just write the ID, and then we put a comma to tell the program to write to the next cell over. And in here we want to write either a 0 or 1, and we got to convert it to a string, so that's what that's for. And it writes either a 0 or 1 depending on if it's vacant or not. And at the end we write a new line, so it goes to the next line for the next parking spot. And then we write the string, and we do that for every single object. And that's how we unload the parking spots. Then the next function is find row by ID. So quick explanation. How do I explain this? So like I said, the parking spots, they are all going to be loaded in and then unloaded at the end, right? But we don't want to do that for a ticket or a vehicle class, because that wouldn't be efficient, and there's no point in loading every single ticket inside of the program. So we got to figure out a way to read the CSV and find the data of whatever ticket we're looking for, right? Because every ticket has its own ID. So we want a way to just read the CSV, find the row with the ticket that we're looking for that is associated with the whatever ID we pass to it, and returns the data. So that's what this function does. So obviously, first thing we do is we pass a file path, because this function is going to work in many different ways. It can work with the tickets, it can work with the vehicles, which is really nice about it. It just does it depending on whatever file path we pass into it, and a few assumptions, rules we got to follow when we write to these, when we write to the CSV files and when we create the CSV files. So it takes the file path, and then it takes the target ID of whatever row we want to read. So what it does, it obviously opens the file at the current file path, and we set the mode to R, and again as file, so that's just how to read a file. And then we also have to import the CSV module, which has a really nice function. So first thing, we create a variable called CSV file, and we set it to whatever is returned by CSV.dictionaryReader, and then we pass in the file. So hold on. Okay, so what the dictionary reader does is, inside a CSV file, it reads the headers and it reads all the cells below it, and it creates a dictionary for each one of those rows. And for those dictionaries, the key is going to be the header for whatever cell is. So if on the far side, whatever this is, if it's an ID column, the ID is going to be the header. So say it reads this row, it's going to set that whatever is contained in that cell as a value, and then the key is going to be ID, if that makes sense. So it's going to read the entire file, and depending on the headers, which is why we want to make sure we have headers, it's going to return a dictionary. So for the tickets class, it's going to have 4 columns, and it's going to have 4 headers. The first header is going to be ID. So this is going to return a dictionary, and with the key, and in the dictionary, when you pass in the key ID, it's going to return the ID, if that makes sense. So it basically returns a dictionary using the headers. So now, but it's going to do that for every single row, right? And we don't want every single row. We only want the one that is associated with the ID that we're looking for. So what we do is, for row in CSV Reader, it's going to go through every single dictionary that it passes back. We're going to pass in the ID key, and we're going to check if that ID matches the target ID. We return the entire row, which is going to be a dictionary. And then, so it's going to go through every single dictionary that this function returns until an ID matches, and we return it once it matches. But if it never does, we just return none. So that's how it works. So when we want to use this, we just pass in whatever file path, whatever the path of whatever CSV we want to read, and the ID. But in order for this to work, we got to make sure that our CSV files all have an ID header, because it's going to return a dictionary with that ID. And yeah, that's basically it. Now, the next one is delete row by ID. So in this one, we wanted to find the row. Now this one, we want to delete the row with an ID. So same thing, we import the CSV module, and we pass in a file path, and we pass in the target ID of the row that we're looking for. And again, the way this function is going to work is it's going to read the entire file, and it's going to copy it row by row until it reaches a row with an ID that matches the target ID, and it's just going to ignore it and then continue writing everything else. So it's going to read all the rows, but it's going to ignore the ones that have an ID which matches the target ID, and then it's going to it's going to rewrite all those copied rows back into the file. So it kind of deletes it. You know what I mean? It ignores it. So it rewrites. It just copies and then rewrites it back into the file. But the ones that have an ID which matches the target ID, it's going to ignore them, and that's how we delete it. So that's what this function does. It's a lot, so that's why I'm going to be just explaining the basics, because I don't want the video to get too long. But now the functions over here do the same thing as the load parking spots and delete parking spots, or unload parking spots, but for different objects. The load ticket takes an ID and it reads the CSV using the find row by ID, and it parses it all in together into a ticket object and returns that ticket object. So basically, you pass the ID of whatever ticket you're looking for, and it returns the ticket with that associated ID. And then drop ticket basically deletes that ticket from the CSV, and the way it works is you pass in the ticket you want to delete from the CSV, and then it handles the rest on its own. It deletes the CSV. Then add ticket, you pass in a ticket and it adds that ticket into the CSV to keep record of it, and that's how it works. Then load car does the same thing as load ticket. You pass some sort of ID. For a car, it's a license plate, so you pass in the license plate of the car that you're looking for, and it returns the car object of that car. And then the same thing for car, you pass in the car that you want to add to the CSV, and it adds it to the CSV. Then drop car deletes the car from the CSV, and yeah. And then load truck is the same thing as car. It loads the truck with the license plate, or it adds the truck to a CSV, or you can delete the truck from the CSV. Then the final function is this one over here. Is this one over here, which is a create nano UID. Basically what it does, it just generates a UID, but then cuts it short. And we use a UUID as the ID for the tickets. So we make sure, there can never be a clash in IDs, because we're going to generate the IDs for the tickets. And actually, it could, in some miracle, clash, but the chances of that is super low, so we can just assume it's never going to clash with the IDs. Basically, it just returns a random UUID. And then over here, give me a second. Sorry, I realized I'm not sure, for some reason one of my cells was deleted that had a function that we needed. But going on, the last two functions are park car and unparked car. Basically, we're just going to use these functions to when we want to park a car or unpark it. As you can see, it's just a wrapper for the add ticket and drop ticket, and add car and drop car. It's just a wrapper. All you got to do is pass in the ticket of the ticket and the vehicle that you want to park, and it handles it all its own by calling the function that we talked about. So it adds a ticket. It's just a wrapper for add ticket, adds a ticket, adds a ticket, and then the only other thing it does, it checks what's the vehicle type. Again, that's why we added that attribute to a ticket object. Vehicle type, so it checks if it's a car, it adds it to the cars, and else it's got to be a truck, so it adds it to a truck. and it does the same thing for unparked car. First thing we do is we drop the ticket associated to the parked car, and if it's a car, we drop the car. If it's a truck, we drop the truck, and that's all these functions do. So now going into the program itself, the first thing we got to do, or the first thing we got to do, the first time running this program, is you got to populate your CSV files into your machine in order for the program to actually work. So that's what this script does. It just calls the create CSV functions I talked about. It runs them all, and it loads the CSVs into your program. And then over here is the actual driver. This is the one that we're going to be, it's the entry point into the program, and every time you want to use it, this is the program that you run. So the first thing we do is we import system, because we're going to use that in the program. And then what we do over here is we load the parking spots so we can work with them, and we load them using the load parking spots function that I talked about. So then it loads a dictionary of parking spots into here, and then we want to create a lot, or a parking lot. And the way we do this is by creating a parking lot object. And again, the only thing a parking lot object needs is a dictionary of parking spots, which is what we loaded over here. So we pass it in there. Now we have a lot, which we can use to find an empty parking spot, unpark a car, park a car, whatever we need. And yeah, so that's everything that we need to handle in the beginning. And now we can start talking to the user. So the first thing we do is we just print a greeting, and then the next thing we do is we begin gathering user input. And the first thing we want to figure out is if the user has a parked car or wants to park a car, and then from there we go on. So first thing we do is we initiate a user input. We call it user input 1 because it's going to be the first user input that we get. We just set it to 0. Actually, I could just set it equal to none. That's better. And over here, this is just a way that I like to handle making sure the user actually inputs something that we're expecting. So the first question we're going to ask is, would you like to park a vehicle or manage an already parked vehicle, right? And if they want to park a vehicle, we ask them to enter 1. If they want to manage a parked vehicle, we ask them to enter 2, right? But obviously some user might mistakenly enter something that's not a 1 or a 2, so we want to handle for that. So the way I do this is I just wrap everything inside a while loop, and while user input does not equal one of the inputs we're expecting, which is 1 or 2, we're going to keep asking for an input with the following prompt. So in the beginning, because we set it equal to none, it's gonna enter this loop, right? And it's gonna ask the user, would you like to manage a parked vehicle? And hopefully enter a 1 or a 2. And once they enter a 1 or a 2, user input's already gonna be set equal to whatever they entered, and it's gonna break out of this loop, and it continues down over here. So now that we know if they want to park a vehicle or manage a parked vehicle, we got to make sure, we got to check which choice they make, right? So obviously the 1 represents they want to park a vehicle, right? So if user input equals 1, everything in here handles or is it, no, it's over here. If they enter 1, or if user input equals 1, everything over here handles the process of parking a car or a vehicle. And else, if they enter a 2, everything over here handles the process of managing a parked car. And I'll go over all of this. So if they enter a 1, first of all, the one that we're going to be going over, we want to start gathering input about, all the input we need in order to park the actual vehicle. So to explain it, the goal of this is going to be to get all the input so we can create a ticket class and a vehicle class, and then from there we can just user ticket and vehicle classes and add them to the CSV and set whatever parking spot we give them equal to occupied, and we're done. If they want to park a vehicle, right? So first thing we gotta do though, if they want to park a vehicle, we gotta make sure that there actually is some parking spots open. So the first thing we do is remember the get empty parking spot function from the parking lot class. Basically what it does, it iterates through the parking spot dictionary and checks if there's a parking spot whose vacant attribute is set equal to true. And if it is, it returns it. So that's what this will return, and it returns in here. But if there isn't one, it returns false. So in here, we want to check if it, in case return false, meaning that there is no parking spots. So what we do is, if empty parking spot, which is over here, is equal to false, we print sorry, we're currently at full capacity, and then we system.exit, and it ends the program there. But if it returns an actual parking spot, this is not gonna return true, so we're never even gonna enter this, and we continue on. So if there is open parking spots, we print okay, you wish to park a vehicle, please fill in the following info. The first thing we ask the user is for their full name, so they're gonna enter the full name, and we store it in name, and then we initiate two variables over here, and again, it's better if we just create them as none. So we just initiate two variables that we're gonna need, and the way we initiate this is because we need them at the global level in order to work with them further down below. So the next input we want to ask is what type of vehicle they have, if it's either a car or a truck. And again, we do this the same way we did when we asked the user if they had a parked vehicle or not. We just initiate a random, again, none. We just initiate an empty variable, and again with the while loop, which wraps the input function until the user enters something that meets our expected input. We're gonna keep looping. So we're gonna ask what type of vehicle do you want, and they're gonna enter either a 1 or a 2 if they have a truck, and then it's gonna store them in user input, and it's gonna break out of the loop, right? And hold on. And now we gather the input from the user, so it's either going to be a 1 or a 2 once it gets down over here. So if the user enter 1, it means that they have their vehicle type. Their vehicle is a car, right? Their vehicle type is a car. So we set vehicle type equal to car. Okay, and then this over here is specific to a car because a car has because a car is going to have an attribute of number of doors. We also got to get that user input from the user. So again, on the same way we gather user input with an expected value, with an expected input, we create an empty variable, and then we create another while loop. This one is the way this one works is just an infinite loop, and over here is again, we know it's going to be a car. Sorry, I'm all over the place, but inside here it means that the user inputted a 1, so it means that they have a car, right? So we're going to ask them how many doors they have. So we have an infinite loop, and we ask for the user input. We ask how many doors does your car have, right? So it's going to ask them a prompt, and they're going to input something, and we're going to sort in user input. Okay. So now what we're checking here is that they actually entered an integer, because the number of doors has to be an integer, right? So what we do is we try to cast the user's input into an integer, and if they entered an integer, it should work perfectly fine. So we take that and we sort in other info, which is the variable we set over here, and then we break out of the loop, and it ends there. But if they enter something that's not an input or something that can't be casted into an integer, it's going to return a value error. So we want to accept it, and we print invalid input. Please enter integer, and we continue on with the infinite loop. And it's going to ask them the prompt again until they enter an integer that doesn't return a value error. And yeah, so that's if the user entered a 1, which means they have a car, right? And again, that's what other info stands for. It's either going to store an integer for the number of doors if they have a car, or because the truck has a payload capacity, it could be a payload capacity if the user entered a 2, which means they have a truck. So else again is if they enter a 2. We do the same exact thing, only this time we set vehicle type equal to truck. Again, we gather another user input. This time we're gonna try to figure out the payload capacity. So again, infinite loop, we asking for an input. What is the payload capacity of your truck? If they enter something that's not a float, which means this will return a value error, we print invalid input, please enter a float, and we continue with the loop. And then once they enter something that's a float, it will set other input equal to the float, and we break out of the loop. And yeah, that's it. That's one of the inputs out of the way. Then the next thing is we gotta ask them for the license plate. So we ask them to enter a license plate. This one we don't need to check it for anything because it's just gonna be a string. It'd be impossible to make sure license plate is correct. So we ask them the vehicle license plate. They're gonna enter a license plate, and we store it in license plate. Now over here again, because they're creating they're parking a car, right? So we got to generate a ticket for them. So we got to make sure that we have a unique ticket ID for them. So we call the create nano UID function, which returns a random nano UID, and we store it in ticket ID. And let's see. And with that, we have everything we need to create the objects and then park the car. So from there, we don't need any more user input. This is just handling the system. So first thing we got to do is we got to create a ticket object, and the way we do this is we just set a variable equal to ticket, and we say it's going to be equal to a ticket class, and we pass in the ticket ID we generated over here. We pass in the license plate we ask the user input for. We we pass in the empty parking spot that we got in the beginning. We pass in the ID of the empty parking spot in the beginning, and then we pass in the vehicle type. This all creates a ticket class or ticket object, and then so that is the ticket out of the way. And then the only thing we need to create now is a vehicle object. And the way we do this is we gotta make sure we create the correct type of vehicle, either a car or a truck. So the way we do this is we create a variable, we call it vehicle, and we set equal to none for now, and we check vehicle type. If vehicle type is equal to a car, we set vehicle equal to a car type, and we pass in the license plate, the name, and the other type, which is going to store the number of doors. But if it was a truck, we else, and we set vehicle type equal to a truck, pass in the license plate, the name, and other info, and we set the vehicle in there. So now we have everything we need. We have the ticket and the vehicle object, and then now we just need to park it. So we call park car, we pass in the ticket and the vehicle, which handles adding all that info into the CSV file. And then we just gotta set the parking spot that we took to occupied. So we do lot.set occupied. We pass in the ticket and the parking ID, and it sets that parking spot inside the dictionary to occupied, or to false, which stands for occupied. And then from there, that's all the changes that we needed to the system, and then we just need to write it all back. So we just unload parking spots. We pass in the parking spots, which is a dictionary, and it writes it back into the CSV, and we just print a farewell. So we print, your car was successfully parked. Here's the ticket. Please keep it with you. And we pass in ticket with the ticket ID, and then parking spot with the parking spot ID, and it gives them their ticket ID and their parking spot ID. And that's it if the user wants to park a car. Now we gotta handle if they already have a parked car and they just want to manage the parked car. So again, we do else, which means they want to park the car. They already have a car parked. We print okay, you want to manage a parked car. And what we need to do is we need to figure out, what's your car or what's your ticket. So what we do is we initiate again how we gather user input. We set a variable equal to none at a global level, and while true, which is an infinite loop, we first what's it called? We ask the user for the ticket ID, right? So we ask the user enter the ticket ID, and we store it in ticket ID. Okay. Now we take that ticket ID and we pass it into load ticket, which will return a ticket if there is one, and we store it in ticket. But if there was no ticket found with that ticket ID, it returns none. So what we do is if there's something in ticket, if ticket isn't none, we just break, and ticket over here is now equal to the ticket that we found with the ticket ID. But if it's none, which means we didn't find anything, we print unable to find ticket, please try again, and it continues on until they enter an ID which matches a ticket, and then we can load a ticket and continue on with the program. Now that's pretty much all the user input we need for this step. Then the only thing we need now is to load in the vehicle. So again, we just load in, we take vehicle, we set it equal to none, and then we check the ticket.vehicle type. Again, this is why it's so important to have that vehicle type there. If the ticket type is a car, we take vehicle and we load the car with the vehicle license plate, which is stored in ticket, and it returns a car, and we store it in vehicle. And then else, which means it's equal to truck, we load in the truck into the vehicle with the license plate stored in ticket. And then from there we have and then the last thing we need is we need to get the parking spot that they're currently parked in. And then what we do is we just use a getter for the parking lot, and we pass it in the ID, which returns the parking spot object associated with the ID, and then we store it in there. So now that is all the objects we need. Now the only thing we need to do is figure out what they actually want to do. So we print ticket found, and now we're gonna get another user input. We're gonna ask the user if they wanna just get info about the parking, or if they wanna actually unpark the car. So the way we do this again is just how we gathered user input always. We create a user input variable. This one's the fourth one. We set equal to none, and then for an infinite loop, first we ask the prompt, which of the following functions would you like to perform? And if they want to get parking info, they're gonna enter a 1. If they want to park their car, they're gonna enter a 2. And until they enter a 1 or a 2, we're just gonna print invalid input, please try again. And then once they enter a valid input, we're just gonna break, and it's gonna be stored in user input, either a 1 or a 2. So now, if they enter a 1, it means that they just want to get their user input. So what we do is we just print, okay, here's the info about your ticket, and we just print their info over here. This one over here is if the car is so this is all generic. This is going to be all the info printed. But now, if the user has a car, we print out the number of doors. If they had a truck, we print out a payload capacity. And then finally, we just print out the owner name and where it's parked at. And so yeah, that's nothing crazy. And then else, it meant that they entered a 2, which means they want to park the car. So what we just call the unpark function. We take their we pass in the ticket and the vehicle, and then from here it handles erasing the records of this ticket and this vehicle. And then we set vacant the parking spot they were currently in using the ID attribute of parking spot. and so it's set to vacant, and it makes a change to the parking spots, and then from there we just unload the parking spots by passing in the dictionary, and then that's it. We print your car was successfully unparked. Thank you for choosing us. And that's it. That's the program. Now we can finally give it a run. So we give it a run. Great. We have a first error. Oh, sorry. We gotta run these. We gotta run all these cells, and just so it actually just to make sure the program actually works. We can erase the CSV files. We can erase the CSV files from this folder just to make sure it actually populates them. Okay. So over here, we can run all. We gotta run all the We gotta run all the cells. So now it works. So here we are. Welcome to the parking spot V1. Would you like to park a car or manage an already parked vehicle? So obviously right now when we're first starting this program, we didn't have the CSV files, and now we do. You can see here. So that works. So obviously we don't have a vehicle yet, but we can try it. So say we wanted to park a vehicle even though there isn't one. So we enter a random parking ID, and it says unable to find a ticket. Please try again. And it's gonna keep going on forever until they enter one. So yeah. But we can run it again. So let's reset kernel. Over here. So we run it again. So let's say we do want to park a vehicle. So we enter 1. Okay, you wish to park a vehicle. Please fill in the following info. My name, George Gonzalez. And do I have a car or truck? Let's enter 1 for a car. How many doors does your car have? As for vehicle license plate, let's go and random 1, 2, 3, 4, 5, 6, 7. There we go. Your car was successfully parked. Here's your ticket. Please keep it with you. So we have a ticket ID over there, and we're parked at A1, which is the first parking spot. So let's copy this. Let's run this again. Let's say now we just want to get our info again. So manage a parked vehicle, enter 2. Let's enter the parking ID that we had. And there we go. Ticket found. Which of the following functions would you like to perform? Let's say we want to just get info. Winner 1. And here we are. Car, vehicle type car, license plate, what I entered. Number doors 4. Owner name George. Parked at A1. Let's try it again. Let's park another car. Let's do John Smith. He has a truck. Payload capacity, I don't know, 200, if that means something. License plate, let's do it in reverse. And here we are. Here's your ticket, please keep it with you. And now you can see he's parked at B1, which is new parking spot. So we take it over here. And let's run this again. So now let's manage, let's say he wants to unpark his car. Go enter 2, enter his ticket. And when I unpark the car, oh. Sorry. Oh. For some reason when it has self like that, it was in the, it's a long story. Sorry. Alright, that was a typo in there. Here we are. He wants to unpark his vehicle. Alright, hold on, let me pause this for a second. Okay, sorry. It wasn't working because I had to re-ran the cell after I edited the typo, so it should work now. Just try one more time. Oh crap. Let's see. Okay, so now we gotta go to the CSV file to find the tickets. This also shows how it works in the CSV. See how it's being stored here? There we go. So let's enter the ID. We're gonna park a vehicle. And there we are. Thank you for choosing us. Your car was unparked. And yeah, it works. Now we can read it again. As you can see, it's not there anymore. Yeah, that's how the program works. Thank you for watching. It was a fun class.